Hey, Dylan.
Hi, how's it going?
Good. How are you?
Doing well. Okay. Um, so yeah, I'm having some trouble on some of the homework problems.
Okay.
I was wondering if I could just go over them real quick with you.
Yeah, what I'm going to do, I don't think you've done this with me yet, but what I'm going to do is I'm going to share my screen. You're going to tell me what problem you're having trouble with, and I'm going to show you a problem that's very similar to it. Okay?
Okay. Okay. Let me pull it up here.
It's just easier just because I can show you all the work for it, and you can just you can understand the problem and then do the homework yourself.
Right, yeah, that makes sense. Um, okay, let me split my screen.
So let's see. It's had to be 1 to 3, 2 or 3, 3, maybe 3. What section?
Oh, right now it's 3-1 to 3-2 that I'm working on.
Okay. And what question number? Because I'll pull up one and I'll share my screen with you, and it'll be very similar to the one you're working on.
Okay. Right now I'm working on question number 26
On 3-1 or 3-2?
on 3-1, sorry.
Okay, no problem. All right, let me share my screen. Okay, so does this look similar?
Yes.
Okay, so here I'm going to show you the solution, and then I'll explain each step. And if you still don't understand, we'll write it down together, okay?
Okay.
All right.
Okay. So 30t to the fifth, I understand.
Wait, sorry, I need to find the original problem here.
Okay.
Yeah, so, oh, this is the answer. Sorry, here's the question. Okay, sorry.
Yeah.
So, yeah, 30t to the fifth, that makes sense
Right.
here. Then
Uh,
here you would have, this would be 10 times t to the 1/2 power,
okay.
right? So then and remember, this is a constant multiple, so this just comes out, right? This is t to the positive 1/2 power, so it would be 1/2 times t to the negative 1/2 power, right?
Yeah. Okay. So you're just completely dropping that negative 10.
Well, no, because what happens is the 1/2, since this is t to the 1/2 power,
Right.
if we multiply t to the 1/2 by 10, that's how we're getting
Uh,
5 right here.
gotcha.
And then
Okay.
this is just it would be like 1 over t times 2, and 1 over t is the same thing as t to the negative 1 power.
So it'll be like 1 over t times 2, which is t to the negative 1 power.
Yeah, it would be 2 times t to the negative 1 power. Yeah.
Gotcha. Because mine is 3 over t, so that would just be like 1 over t to the negative third power.
So it would be 3 times t to the negative 1 power. And then you would differentiate that using the power rule.
3 times t to the negative 1. So then that would turn into 3 times t to the negative 1.
Here, let me
Just
just do this
then,
again.
okay.
I want to make sure you understand, and this will come up a lot.
Okay.
All right, so we know that this is 30t to the fifth. Actually, let's just rewrite this. This is like 5t to the sixth
Mhm.
minus 10t to the 1/2.
Right.
plus 2 times t to the -1 power.
Okay.
So 1 over t is the same thing as t to the -1.
Okay. Gotcha. So.
So
it's
this we've got
30
30t to the 5th.
Right.
This 1/2 times 10 is 5. T
Minus
to
5
the
t.
-1/2, right? Because we have to
Subtracting 1, right?
Yep.
Okay.
This would be -2, right? Because the -1 times the 2, -2 t to the -2 power. And then you got to get rid of all the negative exponents, right? So this stays the same.
Okay.
T to the 1/2 comes on the bottom, and that's the same thing as square root of t. This would be minus 2 over t squared.
Okay. So if you have a negative exponent, you're throwing it to the bottom there,
Correct.
and you're gonna put it back into those.
Like square root, yep.
Okay. Gotcha. That makes sense. Okay. That makes a lot more sense.
All right, let's see. Let's go back to Wiley. All right, and what else?
Um,
Oh, no, sorry, that's the wrong Riley. Let me go back to your session. There we go. Okay.
can we do section 3.2, question 3? I feel like this one should be easy, but I got it wrong twice, so I just want to make sure I'm on the right page here.
So it looks something like this, right?
Right, yeah, yeah.
So you know the power rule for this is just 9x to the 8th. We got that.
Uh-huh.
And when you have something to a to the x power, then you're going to use the rule that it's ln of a times a to the x. But you have to put parentheses around the 9.
Okay. Okay, that makes sense. Let me try that one real quick.
Okay.
Make sure I'm over here. Plus. 7 times 7 to the x. Yeah, it's still telling me I'm incorrect. I don't know why it's.
What number is it? I'll fix it for you.
It was number it was 3.2, question 3.
I think somebody else said there might be something with that problem. Let me check it out.
Yeah.
I'm just looking at what you put.
Did I put that wrong?
Oh, question 3?
Yeah, question 3, section 3.2.
Oh, right. Okay. Oh, you did the ln stuff right, but the power rule on the first attempt anyway, you did wrong.
Oh, I see what I did. I switched the 6 and the 7.
Okay, so what I'm going to do is I'm just going to reset this so you have more chances, okay?
Okay, thank you.
Uh-huh. Okay, you should be okay.
Okay, let me try and refresh the page here. What did I say? Section 3.2, question 3.
Mm-hmm.
Okay, so subtract this. So it's 6x to the 5th plus ln 6 to the 6th. Okay. Got it. I don't like why it keeps telling me I'm wrong.
Hang on.
Oh, I didn't put it to the power. I'm losing it. Okay, sorry. Let me do one more.
Okay.
Sorry, I'm really bad with doing math on computers. I just like 7x to the 6 plus 7 to the x. Okay, please. Finally. All right. Sorry, that took so long. I had a question on one more concept. So it's the same thing if I were to have like 4 times 4 to the t plus 6 times 6 to the t.
So I'm sorry. Say it again.
So for those questions where it's like 4 times 4 to the t power plus 6 times 6 to the t power, just like same thing with the ln.
Yeah.
Okay, that's probably fine then. Let me check another one out. The ones where it's, can we go over 3.2 question 11?
3.2. Did you say question 11?
Yes.
Okay. Let me share my screen again. Okay, so here we're taking the derivative of e to the 0.6 t power.
Mm.
So we're using the chain rule here, right? So
Right.
the derivative of the outside function would just be e to the x, where we don't mess with that inside function. And then we multiply it by the derivative of the inside function. And the derivative of the inside function is just 0.6, right? Because it's the
Right.
constant on the outside.
Oh,
So then all I'm doing is moving this 0.6 to the front. Make sure you put parentheses around this exponent.
okay. So, okay, that makes sense. So yeah, I have like a e to the 0.8 t. So it's basically just throwing that 0.8 to the front. Add my e to the power of 0.8 t in parentheses.
Make sure it's a exponent too. Do you have that as an exponent?
Yes.
Okay.
Let me try it. Okay. Yeah, that makes sense. Couple more. Do you have extra time? Like, I don't want to take any of your time away from anything you need to do.
It's okay. Just go ahead. I'm here for you.
Okay. Could we go over section 3.2, question 23?
All right. So the derivative of a number is just 0, right? So that goes away, right?
Yes.
So the 7 is gone. You can see my screen, right? I'm presenting. Yeah.
Yeah.
And then the derivative of ln of x is just 1 over x, right? And since we're subtracting, we're just bringing that negative with us.
Okay. So just -1/p. Okay.
Yep.
That makes sense. Okay. And so when we have questions where we're using the E and it's saying like find, oh wait, I'm sorry. Actually, could we just go over section 3.2, question 39? Just tangent line questions.
Find the equation of the tangent line to that function at x is equal to 9. So what they're asking you to do is just find the derivative of this, right?
Right.
And then use point slope form, basically. Let's see if they give a good explanation. Otherwise, we can do it together.
Okay.
So we need a point and a slope, right?
Right.
And they tell you they're interested in everything at 9. So if you put 9 in the original equation, you're going to get this. So this is a point on the line, 9 and 1.488.
And that E is Euler's, right?
Yeah, E is, yeah.
Okay.
It's not just a variable. Yeah, it's E.
Okay.
So now we have a point. All we need is the slope. And if we put the slope, or we put, let's see, first here, we're finding the derivative of this function. Do that using the chain rule, right?
Right.
And then we put 9 into the derivative, and what we end up getting out is the slope. So we do this to find the point, and we find the derivative, and then the derivative at the number they're giving us to find the slope. Then we can just use this equation and just plug everything in and then solve for y.
Okay. All right, let me try this one real quick. So plug in 9x. So do you remember Euler's off the top of your head? I'm sure you do, but I can't remember it.
Why are you calculating it?
Because don't you have to, do we just leave it as E?
Well, you should have E on your calculator. Don't you have E on your calculator?
Well, I'm using my phone calculator. My regular one's over here.
Oh, let's see. 2 point something.
I'll just-
2.718.
Okay,
2.718.
gotcha. So 9E. So 9E to negative 0.8. It's 0.0067. So y is 0.067. X is 9. So now I have my y and my x, and I'm finding slope by plugging them in.
You're going to plug in 9 into the derivative. So you first have to find the derivative of the original function.
Okay. And I do that by and that would just be negative 0.8. Can I share my screen for a second?
Yeah, sure.
And just kind of show you what I'm working with here. All right. Oh, do you mind enabling it?
Okay, you should be able to now.
Okay. It's still not letting me for some reason. Yeah, it's still saying host disabled. Participant screen sharing.
Let me see. All right, well, let's just see what you have. All right, what was your original problem?
It's 9e to the negative 0.8x at x equals 9.
This is a x like this. And they want you to find it at 9?
Yeah, at x equals 9.
Okay. So first we're going to find f of 9. And you got something, what'd you get? 0 point what?
I got 0.0067.
Okay, and now we're going to do the derivative.
Mhm.
So the derivative is going to be 9, because that's a constant e
Yeah.
to the negative 0.8x. That's, and then we're using the chain rule here. So the outside function is e to the x, only we're going to leave that inside function alone. And then we have to multiply by negative 0.8.
So it's like 9 times negative 0.8 e to the x.
Yeah, and then times e to the negative, well, yeah, no, we would just simplify this part actually. So 9 times 0.8, 7.2. So now we just want to find f of 9. So you just plug 9 in.
Oh, sorry. Are you screen sharing?
Oh, no, I guess I'm not. I'm supposed to be.
Sorry. Okay.
See it?
So yes. So that there 9e to negative 0.x, and you're putting. Okay, so you're just multiplying the 9 and the negative 0.8 to get 7.2. And then just e to the negative. So you're keeping that negative 0.8 and that power there. I see.
Yeah, that's just a chain rule. So then from here, all you're going to do is you're going to plug in your y1. So here's your x1, here's your y1, right? You're going to plug in your x1 and your y1, and the slope goes in here,
and
then just solve for y.
Negative 0.8 times 9. Gotcha. Put it on the calculator.
You can do that on your own, right?
Yeah.
Okay, what other problems? Is there anything we can do real quick?
Yes. Let me do it real quick. Where is it? 3.2 section 3.2 question 6.
Question what?
6.
6.
Yes.
All right, so we're you have a to the x power, right? So that's where you do ln of the a value
Mhm.
and times the a value of x, right?
Right.
And then, what's this? So let me grab this. Well, actually, let's just do this. So they're rewriting this like, oh, I see, like 5x plus 8x to the negative 3 power, right? Because this is a fraction. So you're going to move that up and make the exponent negative.
Okay.
And then just do the derivative from there. So
Okay,
here's
so
negative 24x to the negative 4th power, right?
yeah. So negative. Okay, so then you go. So I'm confused how they get that fraction at the end there after they make it into 8x to the negative third power.
Oh, because this is x to the negative 4th power, and you can't have negative exponents in your final answer, so you move this to the denominator and make the exponent positive.
Oh, okay. Got it. Okay, so then okay. Let me try that one real quick. Um, let me try this one. Oh wait, how did that? Yeah,
Probably need a calculator.
yeah, I'm trying to. So yeah, I got the first part.
If you turn your thing sideways, can you get E?
Can I hit E?
Yeah, there is E on your if you turn your phone sideways.
Yeah. Oh, I'm using my calculator now. I'm
Okay,
looking.
yeah, you should definitely be doing that.
Okay, so then I'm just confused.
I need to start class right now. Sorry.
Okay, that's fine. That's fine.
Okay.
Thank you so much for your help.
Yeah, you're welcome. I'm glad I could help. That's great.
I'll see you in class.
Okay.
All right, bye.
Guys, I need just 1 minute. I was just working with a student. I'll be right back. All right, all set. How's everybody doing so far? And you all got the message. You all knew that I think I announced it last class too, that today was going to be an online class. But did you guys get an alert that I put a announcement on Moodle also? Did you guys get that alert? Oops. All right, come on, guys. Camera's on. I want to see your faces. Thank you. All right. So how do we do with the homework? How are you guys liking derivatives, the formulas? They're kind of fun, right? A lot of it is remembering algebra stuff too, like, you know, writing the square root of something as something to the 1/2 power, or if you have a negative exponent, remembering to move it to the denominator and make it a positive exponent. So just remember that kind of stuff when you're giving your final answers in Wiley, that you don't want to have any negative exponents in your final answer. Okay, so you just move it to the bottom. I just worked with somebody earlier that I think was forgetting that algebraic rule. All right, so you guys doing okay with the Wiley homework so far? I did change the date on that. That is now not due until March 17th, which it would be tonight. So it was due on the 14th and I made it due on the 17th. So not until tonight at midnight. Okay. So we're going to get started on some other rules. One is called the product rule and the other one is called the quotient rule. And it basically tells you what to do if you have a product, like one thing multiplied by another thing, and you want to take the derivative of that expression, or if you have a quotient, right? So if you have a fraction and you want to take the derivative of a fraction, you can't just take the derivative of each thing. You can only do that with addition and subtraction. So when you have multiplication or division, you have to follow a very specific formula. And this is the formula for the product rule. This is basically saying that if you have a product that you want to take the derivative of, you have to do this in a very special order. You have to first take the derivative of the first function and multiply it by the second function, and then add it to the first function left alone, and then multiply that by the derivative of the second function. Oh, that's my popular today. My goodness. I need to turn my phone off. Okay. So, and then I like how they put this in words. The derivative of a product is the derivative of the first. Whoops. Where are you going here? There you go. All right. So in words, the derivative of a product is the derivative of the first times the second plus the first times the derivative of the second. So derivative of the first times the second plus the first times the derivative of the second. So this is one of the easier rules to do, because all you're doing is just following a formula. All right, so let's write the formula down very explicitly here. So we got f prime g plus fg prime. And then let's make sure we all understand what that means. This means take the derivative of f and multiply it by g, and then take f and multiply it by the derivative of g. Okay, so we have the derivative of f. So this would be, I'm going to just do, I won't do this for every example, but let's just be very explicit. So this would be the derivative of x squared times e to the 2x, so we're just going to leave it alone, plus the function f, which is just x squared, times the derivative of g, which is e to the 2x. Now you don't have to write these steps down every time. I'm trying to tie in what we're giving you here with what we've always said, you know, the derivative of something. That's the same thing as f prime. And then I'm just filling in the f and the g. So now I'm going to execute this formula by taking the derivative of x squared, which is just 2x to the first, right? And then I'm going to leave e to the 2x alone. Then I'm going to leave x squared alone and take the derivative of e to the 2x. So e to the 2x, remember, if you want to take the derivative of e to the kt power, it's just going to be ke to the kt power. So this is just going to be 2 times e to the 2x. So now all we're going to do is we're going to clean this up a little bit. So this is okay the way it is, 2x e to the 2x plus this we should clean up to 2x squared e to the 2x. And then what we could do too to make this formula even simpler is factor out the e to the 2x. So e to the 2x times 2x would be that first term. And then e to the 2x plus 2x or times 2x squared would give you that second term. So in Wiley, it's a little bit picky. But generally speaking, in Wiley, either one of these would be acceptable. Why does that look weird? But if you're getting a funky thing and you're starting to get frustrated, just remember that maybe what they want you to do is to factor out the e to the 2x. I've been looking over the problems, and sometimes they will accept either one of those answers, and other times they want you to factor out the e to the 2x. So I just wanted to let you know that, because if you get, like, you start doing problems and you're entering this and it's fine, and then all of a sudden they're not taking that, try just factoring out a little bit more to make it a shorter problem. All right. So that's the product rule. Oh, and we should point out that this is your F and this is your G. Okay, so again, we're going to do F prime G plus F G prime. Remember, I'm telling you, even on a test, you don't have to write all these steps down. I just want to be very explicit when I give you the first couple of examples, and then we'll start shortening it up a little bit. Okay, so what this means is we want the derivative of F, and we're going to multiply that by G, and then we're going to take F and multiply it by the derivative of G. So let's put in, let's see, derivative d over dt, and our F function is here, and our G function is here. Okay, so our F function is t cubed times our G function is a natural log of t plus 1. And then we're going to take our F function and leave it alone. So t cubed times the derivative of the G function, which is the natural log of t plus 1. Okay, so now we're just going to execute the program or the formula. And remember, you don't have to show this first or this second step. I'm just going to show it just for the first couple of examples. Okay, so let's see. The derivative of t cubed is using the power rule is just 3t squared. Now we're going to leave the natural log of t plus 1 alone. And we're also going to leave t cubed alone. And now we're going to take the derivative of the natural log of t plus 1. Well, we have to use the chain rule here. But you will soon realize that well, I'll do it and then I'll show you. So this would end up being 1 over t plus 1, right? Because the natural log of x is just 1 over x. But then we would have to multiply that by the derivative of t plus 1 using the chain rule. But the reason why you don't really have to do that step is because what is the derivative of t plus 1? Well, you know that the derivative of 1 is just 0, right? Because the derivative of any constant goes away, right? And the derivative of t would just be the coefficient, which is 1, right? So really, this is just multiplying 1 over t plus 1 by 1, because the inner function's derivative is actually equal to 1. So you don't have to necessarily show that step if you recognize that, but you can. All right, let's see if we can simplify this up a little bit better here. Where did I get 2t? 3t squared. ln of that plus. I'm gonna worry about that. I'm doing that thing I do again in my notes where it's like, no, that's not right. Okay, so we'll just get 3t squared. Why in the world did I get 2t? And then, of course, we don't need this plus 1 times 1. So the only other thing that you could do is put t cubed on the top and t plus 1 on the bottom. And you're done. I hate when I do that. Like, wait, where am I getting that number? I don't know, trying to do too many things at once, probably. All right, any questions there? Love to see your nice faces, people. Come on. I have my camera on. It's only fair. Thank you. All right, so here's your F and here's your G in the formula. So F prime G plus FG prime. So I'm going to skip a little step here. We're going to take the derivative of F, which is 3x squared plus 5x, and multiply it by the G function, which is e to the x. And then we're going to add the F function without doing anything to it, 3x squared plus 5x. And then we're going to take the derivative of G, which is e to the x. All right, now just execute this. The derivative of 3x squared plus 5x is just 6x plus 5. We can multiply that by e to the x. And then this is just going to stay the same, 3x squared plus 5x times e to the x. And now what you can do is you can factor out the e to the x. So e to the x, oops, make sure that looks like an exponent. E to the x times 6x plus 5 plus 3x squared plus 5x. And then don't forget here to add like terms, right? So what do we have? 6x and 5x. So we're going to say 3x squared plus 11x plus 5. Let me let you catch up. Looks like you guys are still writing. Okay, so no questions? Is the pace okay? Are you guys comfortable? Give me thumbs up if pace is okay or thumbs down if it's not. All right, cool. But please tell me, because I like this stuff and I get a little excited, and sometimes I do tend to go a little bit fast. So all you have to say is slow down to say, okay? Matter of fact, I'll even put where's the chat? Where is the chat? Oh, it's in more, right? Here we go. All right, I got that message. Philippe, you say your camera's not working. Or maybe it's just a bad hair day for you, right? I have those days too. Okay. All right, here's the next problem. The first thing we're going to do with this is rewrite it with a negative exponent. So this is the same thing as e to the 2t power times 1 over t, right? Which is equal to e to the 2t power times t to the negative 1. Get rid of the fractions, write it the negative exponent. And there's a benefit to doing that too, because the quotient rule is a lot longer than the product rule. So if you can write it as a product, you should, because it's a lot less work than using the product rule. And you'll see the quotient rule. You'll see we're going to do that in a minute. Okay, so we're going to take f prime g plus f g prime. So f prime, I'm going to write it out the long way. You guys do not have to. But I just want you to remember what f prime means. So we're going to take the derivative of f, which happens to be e to the 2t power, multiply that by g, which is, oh, here's my f and here's my g, which is t to the negative 1. Then I'm going to take f, leave it alone, e to the 2t, and multiply it by the derivative of g, which is t to the negative 1. All right, so now I'm just going to execute this formula. The derivative of e to the 2t, we have to use the chain rule, right? And so it would be 2e to the 2t power times t to the negative 1 plus e to the 2t. I'm going to just leave that alone, but I'm going to take the derivative of t to the negative 1. So that would be equal to negative 1 t to the negative 2 power. All right, now remember what I said before about the negative exponents. You don't want negative exponents in your final answers. So what we're going to do is we're just going to move it to the bottom. So 2e to the 2t all over t to the first power, or just t, plus, oh, actually, this is going to turn into a minus sign because we're multiplying a positive e to the 2t by a negative 1t to the negative 2 power. So this is going to be a minus sign. And e to the 2t would be on top, and on the bottom is just t squared. Everybody okay? Grady, Richard, Connor, Thomas, Sean, I think you already told me that your camera's not working today. You're gonna get it fixed though. Thomas, Will, come on, I want to see your faces, please. Thanks, guys. Okay, so now here I'm getting all excited. I say, here we use the product rule and the chain rule, but we've already done that, so it's not that exciting, right? Because we did it on the first page, we used the chain rule. All right, so the first function is f, which is t. The second function is your g function. All right, so if we do f prime g plus fg prime, that means we're taking the derivative of the f function, which is t, multiplying that by g function, which is e to the negative 8t power, adding that to the original f function, which is just t, multiplying that by the derivative of the g function, which is e to the negative 8t power. Okay, so now we're going to execute this. So the derivative of t is what, guys?
1.
Thank you. So we have 1 times e to the negative 8t, and we're not taking the derivative of that, so we're leaving that alone. Then we're going to leave this t alone this time, and now we're going to take the derivative of e to the negative 8t power. What's the derivative of e to the negative 8t power?
Negative 8e to the negative 8t power. Excellent.
All right, so let's see if we can clean this up a little bit. We definitely can do something here, negative 8t. And then because it's a negative 8, we'll make this minus 8t e to the negative 8. And then here you can factor out e to the negative 8t, right? So it would be 1 minus 8t. And again, you should be able to put either one of these in. If you're going to use a derivative as a formula, right, and try different numbers, that like if say you wanted to find like f prime of 10, 11, and 12, and 13, well, you would want the simplest formula possible, right? But I think Wiley does accept both of these answers. I guess because I'm a math teacher, I go a little further than I maybe need to. All right, any questions on that one? All right, let me give you a chance to do this one on your own. I just want to point out one thing, and that is that this is your F, and this is your G. And the 6, since it's a constant multiple, we can just take it out to the side, right? And that'll just go in our final answer. So you want to try that on your own? Awesome. Tell me when you get an answer. Or just type it in the chat. Anyone have it yet? Do we need help? Or you just need a minute more? Anybody have it yet?
I think I got it.
All right, go for it, Matt. What'd you get?
I got 6 e to the x plus x e to the x.
That is correct. Now you could have factored out the e to the x, right? Also, but like I said, Wiley accepts this too. All right, so let's do it. Let's see. We know that 6 is going to come out. So then we're going to do f prime g plus fg prime. We've got 6 times the derivative of the f function, which is x, times the g function, which is e to the x. Now we have x by itself, or sorry, f by itself with this just x, and g prime would be the derivative of e to the x. So what's the derivative of x? What's this part? What's the derivative of x?
1.
Yeah, it's just 1, right? Anytime a variable is all by itself, its derivative is 1. So we've got 6 times 1 times e to the x plus x times the derivative of e to the x is just e to the x. So you have 6 e to the x plus x e to the x, which can be factored further. But either one of these is okay. All right. Who was that? Matt, right? Matt Driscoll, thank you. Oh, you guys need to see that? Everybody ready to move on? Nod your head, yes, just like if you were in a classroom with me. Okay, great. Thanks. Okay, so example 5, demand curve for a product has that equation where P is the price and Q is the quantity sold. Find the revenue as a function of quantity sold. So revenue, if you recall, is going to be the price times the quantity sold, right? So we could say the price, this, times the quantity would be the revenue. So we would have 80 e to the negative 0.003q times q. So let's make that look a little nicer. 80q e to the negative 0.0. Where's the point? 0 here. 0.003q. No, there's only 2 zeros, sorry. 2 zeros there. There we go. So we made it look a little bit nicer. Now, if we want to find the marginal revenue, marginal anything means derivative, right? So we're going to take the derivative of 80q e to the negative 0.003 q. So we can say 80q is your f, or you can just take 80 out, doesn't matter. And e here is your g. So f prime g times f g prime. We're going to take the derivative of 80q, multiply it by e to the negative 0.003 q. Sorry, this should be plus. Plus, leave 80q alone this time and multiply it by the derivative of your g function, which is e to the negative 0.003 q. Okay, now we're going to execute it. Let's see, the derivative of 80q is just 80, right? Because the derivative of q is just 1, and 1 times 80 would give you 80. This would actually be, let's see, the derivative of that, would be, so we'd have 80q, and then the derivative of that would be negative 0.003 times e to the negative 0.003 q. So this will stay the same. And what we're going to do here is we're going to take this 80 and multiply it by this negative 0.003 to get a negative we get minus 0.24 q, and then just bring down the e to the negative 0.003 q. So you could leave it like that, or you could factor out e to the negative 0.003 q to get 80 minus 0.24 q. Again, either one of these. The second one, you don't have to type as much, which is nice. All right, so that's the product rule. We're gonna spend the rest of the class going over the quotient rule. Are there any questions on the product rule? It's really just a formula you have to follow, right? And I find that if I write the d over dt, I make a lot fewer mistakes than if I don't write it. So it's totally up to you, right? If you guys can just do f prime in your head and write it down and then write g, that's fine. But when I do that, I make more mistakes. So again, you don't have to do this, right? You can go right from the formula to this if you can and you want to, but I don't know. I just find I make a lot more mistakes when I try and do that. All right, onward. Everybody done with that? Or you need a minute? Tell me if you do. Okay. Quotient rule. So this is just another formula, right? And it's just saying the same thing kind of before, right? If you want to take the derivative of f over g, you have to use that formula. So in the numerator, you're going to do f prime g and then subtraction this time minus f g prime, and then put the whole thing over whatever g is squared. Okay, so let's try them. Let me make sure I gave you plenty of room. Since I'm the one writing here, I'm going to. Okay, so here's our, oops. Here's our F and here's our G. So if we want to do F over G prime, we're going to do F prime G. Well, you don't need to write the formula again. Let's just do this. Yeah, let's just do this. Let's just follow this formula. Okay, so basically I want to take the derivative of F, which is 5x squared, and multiply it by whatever the G function is, which is x cubed plus 1. And then I'm going to subtract that from the F function, 5x squared, times the derivative of the G function, which is x cubed plus 1. Then divide it by whatever my G function is, squared. Now, unlike in algebra 2, you wouldn't want to FOIL that. You wouldn't want to take x plus x to the third plus 1 and multiply it by x to the third plus 1. So this is the formula, right? So it would just get longer if we multiplied it out, right? So it's in its compact state now. So we're not going to do anything to the bottom. Okay, so what do we have here? The derivative of 5x squared is just 10x to the first. So we're going to multiply that by x cubed plus 1. Subtract, leaving 5x squared alone, and multiplying it by the derivative of x cubed minus x cubed plus 1. What's the derivative of x cubed plus 1?
Three x squared.
Thank you. And then divide it by x cubed plus 1 squared. All right, so the top, we definitely need to get rid of those parentheses, right? Because as you can see, the top is a little messy, right? We can definitely make that more compact. So we're going to just distribute. So you'll get 10x to the fourth plus 10x minus 15x to the fourth all over x cubed plus 1 squared. And then we're just going to add like terms. So 10x to the fourth minus 15x to the fourth is negative 5x to the fourth plus 10x all over x cubed plus 1 squared. And that's your final answer. Everybody get that? The pace is still okay, guys? I'm not going too fast? Okay. Okay, so we're going to do f prime g minus fg prime. So let's identify, here's your f and here's your g. Okay, so I'm going to do the derivative, oops, d over dt of 1, multiply that by 1 plus e to the x, leaving it alone. Then we're subtracting the original function, which is 1 times the derivative of other function g, which is 1 plus e to the x. All of that goes over 1 plus e to the x. That's your g function squared. All right, the derivative of 1 is just 0, right? So don't just think that, and I probably shouldn't say that the derivative of a constant goes away, because it doesn't really go away. It is an actual zero there. And it's important in this one because it's being multiplied by 1 plus e to the x. And anything times 0 is just 0, right? So then we have minus 1 times the derivative of 1 is 0. The derivative of e to the x is just e to the x. So we have 0 minus e to the x all over 1 plus e to the x squared, which is just equal to negative e to the x. All right, so here's our f, here's our g. We're going to do the derivative of f times g minus f times the derivative of g. I'll put that all over g squared. So the derivative of e to the x is just e to the x. And then e to the x stays the same, and then the derivative of x squared is just 2x. X squared squared is just x to the 4th. So we can factor out e to the x here. And you're finished. How you guys feeling about this so far, okay? You have to remember all your differentiation rules, but really it's just a matter of following the formula. And you don't, like I said, you don't have to do the d over dt part, but I find that I make so many fewer mistakes when I write it down, when I include that actual step. It also kind of helps you remember the formula when you write that step down. Are there any questions at all, anybody? I see people still writing, so let me give you a chance. Okay, I think everybody should be done by now. Okay. All right, so here's another example, and they give you all this funky language or whatever. But basically, for here, for example 7, I have an A and a B that I'm going to show you in a minute. But they're asking you here to find the derivative of h at 2. And they're saying that what's going on is you have a product, right? So we're going to use the product rule here. So they want you to find what f of x times g of x is, right? And they're just labeling that action as h of x, as another function. So really they want you to find f of x times g of x, which is the product rule. All right, so the first thing we're going to do is I'm going to give this to you in slightly different notation than I have been, just because Wiley does a lot of different notations. All right, so first thing, before we can find h prime of 2, let's find h prime of x. So according to the product rule, that would be f prime times g, right? And you can write it like this. plus f of x times g prime. All right, so now let's find h prime of 2. Well, according to this, f prime of 2, well, actually, let's just write this down. Let's write it in here. Just so be very explicit. So here you're just going to plug in the numbers. So f prime of 2 is equal to 5, right? Maybe I'll color code this for you. F prime of 2 is equal to 5. Let's see, g of 2 is equal to 3. And f of 2 is equal to 1. And g prime of 2, I already used that color. G prime of 2 is equal to 6. So all you have to do is multiply 15, or 5 and 3 and 1 and 6 to get your answer of 21. So basically they're telling you what f of 2 is and f prime of 2 and g of 2 and g prime of 2 is, and you're just plugging in the numbers is all. It's kind of a simple question. All right, now this one, what we're going to do is we're going to use the quotient rule. Because they're asking us really for a quotient here, right? So let's remember what k prime of x is first for the quotient rule. So you'd have f prime of x times g of x minus f of x. Oh, make this legible, sorry. F of x times g prime of x all over g of x quantity squared. So let's put 2's in here. All right, so let's see, f prime of 2, according to this up here, f prime of 2 is 5, and g of 2 is 3, f of 2 is 1, and g prime of 2 is equal to 6. And g of 2 is 3, and we want to square that. So you get 15 minus 6 over 9, which is 9 over 9, or 1. Any questions, guys? You doing okay? See a few people still writing. All right, moving on. Okay, so h of x is asking you to find a product, right? So they're asking you to find the product of f of x and g of x according to this graph. So if we first want to find h of x, that's going to look like f prime of x times g of x plus f of x times g prime of x. So let's put the 2's in there, f prime of 2, g of 2, plus f of 2 and g prime of 2. So f prime means the slope at that point, right? F, the function f at 2 means what's the y value, right? All right, so let's look at 2. What's the slope of the f function? So we're talking about this function slope at 2. So that would be, actually the slope everywhere between 0 and 4 would be the same, right? So the slope there we could figure out by going rise of 2, run of 1. So we could say the slope at 2 is 2 over 1. And then if we did g of 2, that here's the g function, and we want to know at 2, what is the y value? And actually, I think I didn't draw this very well. I think it's 6. So g of 2 is 6. And then f of 2, we want to be on the f function at 2, and that would be here. F of 2 is 4. And g prime means the slope. So the slope at 2 on g, oops, sorry, use that color. So g prime of 2. So on the g graph, the slope is the same everywhere. So it wouldn't matter anywhere on the graph. It's always going to be the same, right? But at this particular point here, it's going to be, let's see, rise, -8, run, +8. So, or no, +8, yeah. So that would be -1. So what is this? 12 plus -4 equals +8. So here we're using the product rule. Right, because that's what h of x represents. In this next problem, oh wait, it's okay. I don't want to rush you guys. Okay, looks like everybody's done. Stop me if you're not. Okay. All right, now this time they want you to find k of 6, and k of 6 is the function up here in the directions that are asking you to divide, right? So you're going to use the quotient rule here. So that would just say f prime of x times g of x minus f of x times g prime of x all over g of x quantity squared. So we're interested in 6, so let's put 6 in there. Oops. All right, so the slope, so f prime of 6 means the slope of function f at 6. So let's see, function f at 6, the slope at 6 is 0. Then g of 6, let's see, on the g function, g of 6 is 2. F of 6 would be the value of on f, the value on f, it would be 8. And then g prime of 6 means they want the slope of the line at 6 of g. So here's g of x, and the slope of g of x is the same everywhere, right? It's just -8 over, oops, I already used that color. Let me use something different. So the slope would just be -8 over 8, or -1, right? And then g of 6, running out of colors here. Let's see, g of 6 just means on function g. Oh, we already know that's 2 here. So g of 6, we already figured that out from up here. So this would be just 2 squared. So you simplify all this and you get 8 over 4, which is equal to 2. And that's it for today. Anybody need any help? I'm happy to stay on for a few minutes. You okay? All right, you guys are free to go.
Thank you.
Thanks.
Thank
you.
Stay
Have a
safe,
good one.
guys. Bye.
Happy St. Patty's Day, by the
Oh
way.
yeah, you too. You guys be safe tonight.